Unit 3, Chapter 1, Petrodiesel versus Biodiesel. In this session, we'll compare the suitability of petrodiesel and biodiesel as transport fuels, mostly with reference to chemical structures. Biodiesel. Remember, biodiesel is simply a mixture of methyl esters. Of course, in reality, we might also have ethyl or propyl esters. They are made using triglycerides, which are naturally occurring in vegetable oils and animal fats. So here, this is our biodiesel. The ester functional group makes this molecule polar. And its non-renewable counterpart, petrodiesel. Petrodiesel is one of the products of fractional distillation of crude oils. Remember, crude oils are mined from the sea. So it is still a mixture, it is not a pure substance. 75% of petrodiesel is alkanes, okay? And the other 25% are aromatic hydrocarbons. The length of alkane ranges from 10 to 15 carbon atoms. As a result, since they're all alkanes, petrodiesel molecules are nonpolar. So, let's examine the intermolecular forces in both fuels. So first of all, for petrodiesel, since they're all alkanes, molecules are nonpolar, so the only intermolecular forces between molecules are the dispersion forces. When it comes to biodiesel, we know that we have ester functional groups in their molecules. So we have part of the molecule partially negative, and this part of the carbon will be partially positive. Therefore, it's blessed with one more layer of intermolecular forces. That's the dipole-dipole attraction between the negative center and the positive center. Okay? So this entire molecule is slightly polar. Okay? Because of the difference in intermolecular forces, they have very different physical properties. For example, in density, biodiesel is slightly more dense than petrodiesel. You can imagine that the extra layer of dipole-dipole attraction will help the molecule to pack closer together. And viscosity. So viscosity measures fluid's resistance to flow due to internal friction. So these two liquids, this orange one is more viscous. You can see that biodiesel is almost twice as viscous as petrodiesel. Okay? It is more thick. Yeah? Cloud point. Cloud point measures the temperature below which crystal starts to form. So it is the lowest temperature to stay as fluid for liquids. Okay? So biodiesel has much higher cloud point than petrodiesel. It means that in winter, biodiesel is more likely to freeze, becoming solid when temperature is low. At the same time, biodiesel is lower in energy content or energy density, however you measure it. Because of these differences, we need to consider when we use them as transport fuels. So first of all, in terms of combustion, biodiesel produces much lower carbon dioxide and polluting gases such as nitrogen monoxide than petrodiesel, thanks to its ingredient. Yeah, it's just the food that we eat that we use to make biodiesel. It's not something that we mine from the land. Okay. However, biodiesel, because of this ester functional group, it's slightly polar, and that makes it more attractive, or you can say that it attracts more water in the air. Yeah, it's more likely to attract water in the air. So it makes biodiesel less efficient in combustion. Also, it might cause engine failure. So we don't want water molecules to be in engines. Yeah? And petrodiesel, because it's nonpolar, it doesn't have this problem. So it's more hydrophobic than biodiesel. And viscosity also has a part to play when we use it for engines. Okay, so biodiesel is more viscous and therefore it's more likely to clog engines.